Hello, everyone. So in this video, I'll talk about the last problems on the chapter test about the trig identities. So this is number 29, and I would like to solve this equation and in between 0 to 2 pi radian, okay? So like we have only one variable, which is sine theta. That's why I will probably start with getting this alone. So I add 3 to both sides, so I should get 4 sine squared theta equals 3, and then divide by 4. And then I will get sine squared theta equals 3/4. Okay, so now I can take the square root of both sides, so that should give us sine theta equals square root of 3/2 if you take the square root. But at the same time, I can get the negative version of this one. Okay, so, or negative square root of 3/2. So the question now you have to ask, like, what value of sine will give us square root of 3/2, right? So like this is one of the common angles which we do need to remember. If you don't, so you can always make a triangle with the common angles like 30, 60, 90s, right? So let's say this is 60, this is 30, and then this was 1, this is √3, and this is 2. And if you are looking for the sine value of √3, so this is going to be opposite 60. 60 is just pi/3. So the data could be pi/3 plus some multiple of like 2 pi k. Because if you add any multiple of 2 pi, then you will get the same value. And the same thing with this guy. So data is equal to like, this is like negative. So if you remember this sine value is also negative in the fourth quadrant. So if this is like pi/3, so we can take the negative pi/3 and plus 2 pi k or whatever. But we want to get the answer in this interval. So if I start with plugging k 0, so my like one angle, I'm gonna call that q1, just pi/3. So this is good. And if I choose another one, like if I choose k2, k is like maybe 1, that will be bigger than like 2 pi, which doesn't give me anything else. So if I choose -1 for k, right, that will be pi/3 minus 2 pi, which is also negative, but we don't want this to happen. So that is why there is no such a thing. But what we can do, like we have to remember the, like when I say the pi/3 plus 2 pi k is one solution, but the sine value is also positive in the second quadrant. So this is one thing we could have, or we could have also like pi minus this angle. Why is that? Because if you remember the second region, right? So the sine value of, let's say this angle is the same as sine value of this, because they have the same y value as long as these are equal, because their y values are like just the same. So this is one angle that could give us square root of 3/2. But also, if you like, let's say assume like this angle is the pi/3, then if you subtract pi/3 from like 180 or pi, you get this angle. So that's also same as terminal point of this like point, right? So terminal side of this line. So that's why we could have another like angle as pi minus this, which is gonna give me 2 pi/3. So I hope that makes sense. So this is just another solution we could have when this is the case. But for this one, I said the negative pi/3 could be one solution to this negative, but you could still have on the third region as well. So third quadrant. So if you add um, like if you add pi to this number, so you will get something in the second quadrant, but we just need to add like pi like to the maybe this number, so we can get another corresponding value in the third quadrant. So like kind of confusing a bit, but let me try showing that as well. So our goal is just to get this angle, right? So let's say this is something. So because the sine value at this angle, so let's say this is 1. Since we want to get the square root of 3, so that means this angle should be 60 degrees. So we can get this is √3, and this is 1, and this is 2. And the sine value of this terminal point is also square root of 3 over 2. So since this is already pi, and then there is like pi third, like more, so then we do have another angle. So let's say this is q like 3. That will be negative pi over 3. And then q4 is just the pi plus pi over 3. So that's just 4 over, like 5 over, is it 5? Like 5 over or 4 over 3? I think it's 4 over 3. So like if you add the pi over 3 to pi, so you get the same the y value as before, and then we got that as another solution. So, but now we have four solution, but four of these solution, like one of these solution is negative, which is like this one, right? So we cannot have the negative because even though that's a solution, but we just like something in this range. So we want to kind of find the corresponding value of this one. So remember, this was 2 pi over 3, and that was the this angle. So like if I just kind of remember, this is 2 pi over 3. So like if you add like pi to this guy, so you will get right opposite. So you will get something right here. So if you add another pi to this, so the like since this is a vertical line, like I mean straight line, so the angle right here is the same as this one, and then these are equal. So the y value of this is gonna be same as y value of this, but in the opposite direction, in the negative sign. So which is why if you add like pi to this guy, so you actually get the another one as 5 pi over 3. So I hope that wasn't too complex. So this is just another solution that we have for this number 29. So let's take a look at the next one. So this is the next problem. So we have like cosine and tangent given in this like equation, which is not really obvious on like what to do. So what I will try, I'll play between one side, so 0 on one side, but that's usually like helps. So I'm gonna go with negative 3 times cosine. Maybe I should change this as well, because like if you remember, one of the basic identities was whenever you have cosine of pi over 2 minus some angle, that was equal to sine of the angle that we're subtracting from pi over 2. And then we can do this other way around as well, so if you need to. And the cosine of pi over 2 minus theta, instead of writing this, I will just replace sine theta. And if you want to really prove this one, you can use the angle difference identity for cosine to get this one by expanding this, which is not needed in this case. And I do subtract tangent theta from both sides. Okay, this is the equation we have, but you know, this is sine, this is tangent, so it's not easier to deal with when you have both. Maybe we can convert into like sine over cosine. So negative 3 times sine theta minus the sine theta over cosine theta, right? And I can multiply both sides by this number, so we can cancel the fractions. So if I multiply this part by cosine theta, so you will get negative 3 times the sine theta times cosine theta, minus, if you multiply this fraction by cosine, the denominator will be gone. So the sine theta will be only the one left over. And we have sine theta, we can factor. So usually factoring is good. So if I take this sine theta, and that will give us negative 3 cosine theta minus 1, and this is equal to 0. So the product of two things is equal to 0, so we should have sine theta is equal to 0, or negative 3 cosine theta minus 1 is equal to 0. So if this sine of something is 0, that's only the case like pi or, pi or 0, because we are looking for in between 0 to 2 pi. So from here, so we can just say theta could be 0 plus any multiple of 2 pi, but we just don't need this one, so just 0 degrees. Or we could have pi plus any like two more of these, like 2 pi's. I'm just writing this because usually it is something we are missing in some questions. I just don't need in this problem, but it's good to still write it. So if you just do that, so you will take the Q1 maybe as like 0, and Q2 is gonna be just pi. That's the solution from this equation, but we have another one. If I like to find the cosine data alone, so in this equation, we got cosine data equals 1 over 3. Well, if you add 1 to both sides, you get 1, and divide by -3, you get 1 over 3, but that is just -1 over 3. And now if you take the inverse cosine, so we can get the data. So you will get the first value of the function. I guess that will give us like 1 point, like let me write that middle step as well. So like, again, when you find the angle, so you take the inverse and then we just use a calculator with this part. If you plug this, you will get something, I guess, decimal. So let me try that. So that is 1.911. So 1.911. And this is one value, but keep this in mind. This is just the one number that does satisfy this equation. So since we want to get a negative value, and that is like -1/3, cosine is negative, is like in the second quadrant or the third. So if this is my one number in the second quadrant, right? So I should find the another one in the third. So let's keep this in mind. So let's say the angle right here is not that great. So like if I assume this is data, and then we'll get this the same x coordinates if this is the same as this one. Okay, so these are equal angles. So like if I know the cosine of this angle is equal to -1 over 3, or the angle is 1 point like whatever, 1.99 like 911. This is in radian. And like the whole thing, this straight line is pi radian. If you subtract this angle from pi, you do get this much, right? So, but what we want is like this angle right here. I mean, let's say this way. So this angle right here is going to be 1.911. So in radian, 1.911. And if you subtract this from pi, you get this data. So that is just the pi minus 1.911. And that will give me this data. But I do need to know the terminal point of this line, this angle. So you start from 0 all the way here is pi, and then plus this data, which means I need to add this to pi so I can get the terminal location of this point. So that's just plus pi. And I hope that's not too complicated. So if you plug this into calculator, so you get another decimal, which is roughly 4.373, I guess. So 4.373. So you can double check. You make sure you do these like calculation part on your own to see if you are really getting those. So that was the number 30.